Welcome back, everybody, and in this installment of Web Tutors, I'm going to be doing problems 14 and 15 from Test 1, Section 3. This is the math section. There are numbers. Alright, let's get into this. If 2x, or the quantity of 2x minus 5 times the quantity of 2x plus 5 equals 5, what is the value of 4x? Alright, well that sounds pretty easy to me. Let's just keep in mind what are we looking for here. Make sure we don't lose sight of the main goal, 4x. So let's see if we can find a 4x in this problem. Well, let's look at it. Let's see what we got right now. We've got 2x minus 5 and 2x plus 5 equals 5. Oops, whoa, that's a 4. Equals 5. Alright, so let's just take a look at this. Do we see a 4x anywhere in this problem right off the bat? Well, I don't. I see 2's and 5's and x's, but no 4x squared. So right here, what we see when you see these double parenthesis things, like the 2 scoops or whatever, we call that basically these are 2 binomials. And pretty much every time you see this, I mean, there'll be very rare instances where you don't want to do this, but a lot of times when you see this setup, the binomials being multiplied together, you go for it and you use the FOIL system. And FOIL is just a little acronym that stands for first, outer, inner, last. I'll explain what that means. It's basically telling you the order that you want to multiply these things. I mean, you could multiply them in any order. This just ensures that you don't forget anything. So when it says first, and the F in oil is first, the F in FOIL. So you want to multiply the first terms together. So we have a 2x and a 2x. What does that get us? We get a 4x squared out of that. Well, that's handy. It looks like we're going to have our 4x squared after all. Alright, good. So I guess I'll jump to a different color for this. Now it's telling us to multiply outer. So first were the first terms. Outer means this term and the other outer term. So the outermost from the center. So 2x times 5. I think that's going to get us 10x. I think that's beyond dispute. Alright, now it's saying inner, pretty simple. The inner 2 minus 10x. And finally, use a nice blue for this. It's saying last. So last means the final 2 terms, which when I multiply negative 5 times positive 5, I should get negative 25. I think that makes sense. Alright, so, and then again, it always will equal the same thing. It's going to be equal to 5. Alright, so we got our 4x squared, which is good because that's what we're looking for. So now we got to get it by itself, right? We want to put this on one side of the equality sign and throw everything else on the other. But before I do that, I'm going to see if I can simplify this. I can see pretty clearly that I have a positive 10x and a negative 10x. Well, if I add 10x to something and then take it away, nothing's really happened, right? So these two cancel out, and it's basically like I added 0. Nothing happens when you add 0. Alright, so let's bring this guy down. Now we have a 4x squared minus 25 equals 5. So that seems pretty doable. I'll just add 25 to both sides. You always do the opposite to get it onto the other side. And I'm left with 4x squared equals 30. So now I'm not solving for x. I don't actually want the variable. I want the entire 4x squared, that entire term. And so it says it's equal to 30. Ring-a-ding-ding. 30 is an answer. Sweet. Alright, moving on. Alright, so this is problem 15. Let's get into it. The coordinates of point A in the figure above are p, r, where the absolute value of p is greater than the absolute value of r. Which of the following could be the slope of AB? Alright, so I'm going to attack this problem assuming that you have no idea about anything that's said here. You've never seen a grid like this before. You've never seen axes before. So I'm going to start from the ground up. Alright, so the very basic thing you should know, the first thing you should know is that this is what we call a coordinate plane. When you see these kind of 2 lines crossing each other, this is a coordinate plane. And what it does, what a coordinate is basically we give directions. We say, all right, we want you to go to this point. Like kind of in Battleship when you would say, all right, A10. That would mean you go over a certain number of spaces and you'd go up a certain number of spaces. And there was a direct spot or coordinate that correlated with whatever instructions you gave. So that's all a coordinate plane is, or that's all a coordinate graph is in this case as well. We just give instructions and that tells us where a specific point is located on the graph. Now to help us further simplify the matter, we've actually named these two axes, or as they're called, the two lines that are intersecting. We have over here the y-axis, and over here, I guess I'll use blue, the x-axis, or x-axis. Alright, so these are our two axes. Everything horizontally is referred to as on the x-axis or in the x direction. Everything vertically is in the y direction. And now we can see that, alright, so if we're going up in the y direction, you could probably say that our y value is going to be positive. Because if we've decided that up means positive, down means negative. We've also decided that for x values, going over to the left means negative, going over to the right means positive. So that basically means that everything in this this quarter of the graph that I've sectioned off here, everything's going to be positive, right? Because everything is up and to the right. So this is called quadrant 1. We have 4 quadrants, and I'll just say that this one has positive, positive, and I'll explain what that means later. Now over here, we can see that y is still positive. We're still in the upwards part of the graph, but we've actually now x has crossed over, our x coordinate has crossed over what's called the origin. That's the very center of the graph, and the origin basically means that we have a 0 value for both x and y. So it's crossed over and now it's in negative territory. So we always are going to put x first, so we'll say our x is negative, our y is positive. Alright, so now going down here, we can see that y has now gone negative, x is still negative. Finally, over here, y is still negative, but x has now crossed back over to the right, so we're seeing a positive there. So those are just basic guidelines to help us remember, alright, so if I have a negative y value and a negative x value, I'm going to be dealing in the third quadrant. It's just an easy way to keep track of everything. Alright, so now that we've covered that, that's actually going to help us in this problem. So let's just go over our notation in these parentheses here. So the way we're always going to do it is we're always going to put the x value first, like I said, then comma, and then the y value. Sounds good? Alright, so for this particular problem, it's saying that our coordinates are p, so our x value is going to be p. Y value is going to be r. Now normally you would see numbers put in there, but they're trying to be tricky on you and put in letters to screw you up, but it's not going to work on us. So it's saying now on this coordinate plane point A. So we can see where point A is. It's right there. It has the coordinates PR. So we know that P is located basically starting from the origin. It's located P in that direction and R upwards. So we went P backwards and R upwards, right? That's why our coordinates are this, and that's how we know where A is, because it told us right there and we have our picture. Now it's also saying P is greater than R, so we know that this X value, or it's saying the absolute value of it. So we're saying that basically the length of P is going to be greater than the length of R. And we can see that, right? You can see that this is much longer than the amount that it went up. It didn't go up very much, but it went out pretty far. So now it's asking which could be the slope of AB. Alright, now slope is a pretty interesting topic. It's the symbol for it is this kind of cursive M. That's going to be our slope. And it's basically saying how steep a line is going to be. So we can see this line. If, say, like we were to put a ball on it, imagine this was like a ramp and we put a ball on it, it would start rolling down, 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 right? That's because this has some slope to it. It has some change in direction. we can see that things are slanting downwards. Therefore, it's going to have a slope. We know it's going to have a slope. But now we have to just figure out what it is. Alright, so what are some things that can help us? Well, normally if we're given a set of points, the most common way we use the points to find the slope is, there's kind of a sing-song way of doing it. It's called the rise over run method, meaning your rise, or your change in the y value. So you're going to have 1 point of y, and the change from a different point of y. So your rise, so how much you've gone up or down, over your run, which is how much you've changed side to side. So rise over run, fun little way to just remember that. Alright, so we know our slope is going to be equal to the change in y over the change in x. Well, how do we know what the change is? Well, we're going to have to choose another point somewhere on this graph. The first point has been chosen for us, it's going to be A. Second point, I'm going to say let's do the origin, because we always know that the origin is going to be 0, 0. So let's just plug that in and see what we get. We're going to have that our y, that I'm going to say we started, so this means our starting y's. So our starting y was, I'll go back to pink. Our starting y was r, and we finished at 0. 0 minus r over. And now we started at p for x, and we ended at 0. So you kind of have to do a little backwards, but that gets you the correct change, so you know it's going to be the correct value. Alright, so we can simplify that into just negative r over negative p. Simplify it even further into just r over p. That works out for us, right? Except none of these are r over p, because they're asking which of the following could be the slope. So we have to see which of them fit all the parameters we've set. So we know we're dealing with r over p, right? What else do we know? We also know that p is going to be greater than r. So let's take a look at our options here. We have negative 2, so that's basically saying 2 or negative 2 over 1. So is 1 greater than 2? No, it's not. So that's not going to be a possibility. We have negative 1/2 here, so it's basically saying that our r value is equal to negative 1, and our p value is equal to 2. So that works out because the absolute value of 2 is greater than the absolute value of negative 1. So this is a possibility. We'll leave that undecided. 0, no, because if it were 0, it would just be a completely horizontal line. It would have no change in its y. 2/3. Okay, so this is another one that kind of fits because it's saying that 3 is greater than 2, which is fine. Finally, 5/2. Again, that's not going to work. Alright, so now we've narrowed it down, so that's good. And let's see if we can work with anything from here. We have negative 1/2 and 2/3 as our option. So they both fit this little statement right here, but now which one of these could be the slope of AB? Alright, so if we're looking at this, we basically have to decide, alright, does this have a negative or positive slope? Because we can see here that this guy has a negative 1/2, and 2/3 has a positive. Alright, so let's just imagine the different kind of graphs these would make. Let's start with 2/3. Saying we started at like the origin, the basic way we use a slope to construct a line is we have our starting point, in this case I chose the origin, and we count it, or we make each new point based on what the slope says. So we start at 0, and it's saying go forward 2, so go forward positive 2, and go up positive 3. Like I said, oh, I'm sorry, I got that backwards. We have to be going up 2 and out positive 3, because we have to have our rise, so we go up 2 over our run, which is out 3. So that means for every point starting from 0, we're going to go up 2 over 3, up 2 over 3, up 2 over 3, keep going, going, going. That also means we can go down 2 and back 3. You can just do the reverse because it's all a line, so it's all going to have the same slope. And let's see, does that look like what we have here? No, it does not. It looks like it's going the opposite way. That's because positive slopes go through these quadrants like this, so they're climbing upwards, whereas a negative slope is going downwards. So let's just quickly make up what negative 1/2 would look like. Say we start from 0, we're going to go down 1 over 2, down 1 over 2. Also, we can go up 1 over 2, up 1 over 2. And we got that. That's looking a little bit more like our line AB here. So I think it's pretty safe to say negative 1/2 is our answer.